Greetings and welcome to our video on factoring algebraic expressions. We are covering a lot of really important topics that lay the foundation for years of math. So let's get into it with factoring. So factoring, this video is going to assume that you've watched the video on the distributive property or expanding using distribution. And so if you have not checked that out, definitely go back and watch that because a lot of connections between these strategies will be based on those. So let's get into it. A couple terms, vocabulary that we are going to be using. Factoring algebraic expressions. This is rewriting expressions as the product of its factors. So we're going to be using some division. We'll be using what we know about greatest common factor and then applying it to our work with algebraic expressions. Essentially, this is using common factors to undo the distribution of a number to terms within a parentheses. And so if we look at this problem, 12i plus 6, I know that this is the result of something times something with an operation in the parentheses. And so we need to figure out what was it that we started with. This is like the after, and this is the before of distribution. So factoring is going to be undoing what we did when we distributed. So if you remember, when we distributed, we took this term and we multiplied it times that number, and then we multiplied it times this number. So for example, if this was like 4 times 10x plus 3, we would do 4 times 10x plus 4 times 3, and that got us 40x plus 12. So now we are going to be starting at this point, and we're going to be looking for what was it before the distribution. So with this, let me quick shrink that out of the way. We can use, if you think of this like division, or if you think of this using factors, we're trying to figure out what number could we have divided both of these numbers by. And another way that we find that is by looking at greatest common factor. With 6 and 12, it's pretty easy. You could just list them out and then see which is the biggest one. But 6 is 1 and 6, a 2 and 3. 12 is a 1 and 12, 2 and 6, 3 and 4. So our greatest common factor in both of these is going to be 6. So that means that we can divide the coefficient and the constant by this number. So we are going to do that here. So if we know our greatest common factor is 6, I'm going to think about this, where 12 divided by 6 is 2. So this 12i can be thought of as a 6 times 2i. And then we're going to be adding, this 6 is equivalent to a 6 times 1. So we've divided both of our terms by 6 and rewrote it using multiplication, because now we can see that this 6 has been distributed to those two other terms. We have two things, the 2i and the 1, that have both been multiplied by 6. And that's what happened when we distributed. We took a term, or we took a number, and we multiplied it by those two terms. So I know that really what we've done is a 6 that came from here and there that was multiplied by a 2i plus 1. So if we pause for a moment and look at this, I know to solve it, if I were to distribute this, if I wanted to check myself, I would do 6 times 2i plus 6 times 1. 6 times 2i is 12i. 6 times 1 is 6. So as you can see, we got the same answer here. Even our expression in this place is the same. But it is before we had factored, or before we had distributed. So your final answer for this problem is right here with 6 times 2i plus 1. So there's another strategy that we can use, and that's with our double ladder method. So if we set this up as 2i plus 6, and we wanted to do our double ladder, I know that I can think of this like there's a 12 and a 6. They can both be divided by 2. and that would leave me with 6i plus 3. Now this 6i plus 3, they can both be divided by 3. 6i divided by 3 is 2i, and 3 divided by 3 is 1. So over here, this is 2 times 3, which is 6. And so we really have 6 times 2i plus 1. Or if we had just taken that 6 out from the beginning, we know we would have 6 times 2i plus 1. 6 times 2i plus 1 equals 12i plus 6. So you could use this double ladder method. You could use this strategy here. I do love this first strategy that we went to because it connects to the distribution, the distributive property, much more clearly than using the double ladder. But either way works. So when we're doing 35 plus 42k and we need to factor this, I'll start out and think, what are my factors? Let's do the double ladder method for this, and then we will see if that matches up with our undoing the distributive property. So I know 35 and 42, I can't divide them by 2 because 35 is odd. Can't divide them by 3 because 35 is not divisible by 3. No 4, no 5, but I do know 7. So I could divide them by 7, and that would leave me with 5 plus 6k. 5 and 6, they cannot be divided by anything, so that's as far as I can go. So really, what I have here is 7 times 5 plus 6k is going to equal 35 plus 42k. And again, I will check that real fast. 7 times 5 plus 7 times 6k. 7 times 5 is 35. 7 times 6 is 42, and that's k. So when I checked myself, this does seem to work out. But let's try rewriting it using our greatest common factor is 7. So I know this 35 is really a 7 times 5, and this 42 is a 7 times 6k. So the number that was distributed to both of those terms was a 7. So that means my 7 is going to go out front, and it was distributed to a 5 plus 6k. So we got the same answer here as we did there. So either strategy works. It's up to your personal preference on them. Let's do another one. This one involves subtraction. For here, you know what? I will use the double ladder again, and we'll check and see how that goes. So 28p minus 36. I know they're both even, so I can pull out a 2. So I'm left with 14p minus 18. They're even again, so I'm going to divide by 2. So I have 7p minus 9. 7 is prime, 9 is only divisible by 3, so that is it. That is all I can do. Now, 2 times 2 is equal to 4, so we have 4 times 7p minus 9. Quick check. 4 times 7p minus 4 times 9. 4 times 7p is 28p minus 36. So we did get the same thing there. Now I will check and see. So we have 28 and we have 36. Let's see, what are all the factors of 28? 1 and 28, 2 and 14, 4 and 7. And that's about it. All the factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. There's a lot of factors there. So the greatest factor that we have in both of those is a 4. So that means if my GCF is 4, I need to think of this like I'm dividing this by 4, and I'm dividing this by 4, and I'm going to write that out expressed using multiplication. 28p divided by 4 is 7p, and this 36 is the same as 4 times 9. So this must have meant that a 4 was distributed to both of those terms. So we have 4 times, and what's left over is a 7p minus 9. So you notice, again, we got the same answer, so I'm feeling pretty good about this. All right, for 45 minus 30g, why don't you try to factor this? Pause the video, and then once you're done, you can hit play again, and we'll see how you did. All right, digging back in, I already recognize that my greatest common factor, my greatest common factor is going to be 15, because I know 15 goes into 30, and it goes into 45, and nothing bigger will do that. So this 45 is really a 15 times 3, and I'm subtracting a 15 times, well, 30 times divided by 15 is 2, so a 15 times 2g. It looks like both terms were multiplied by 15, so that has to be what goes out front, and then I'm left with 3 minus 2g. So 15 times 3 minus 2g. Let's double check using the double ladder. 45 minus 30g. I'm going to start by pulling out a 5. I'm going to pull out a 5. So 45 divided by 5 is 9. 30 divided by 5 is 6. So 9 and 6 are 3 is a factor of both of those. 9 divided by 3 is 3. 6 divided by 3 is 2. So I'm left with 3 minus 2g. And 5 times 3 is 15. So check it out. These are equivalent. And then I can check one more time where let's redo the distribution of this to see how did we do. 15 times 3 minus 15 times 2g. 15 times 3 is 45. 15 times 2 is 30. And that checks out. Good to go. So that is factoring algebraic expressions, and it is definitely very closely connected to the distributive property. You could almost think of factoring like it is undoing the distribution. So try to connect those two and help yourself along.